adding the Cartesian, this Airy stress function. The Airy stress function is purposefully added in Cartesian coordinate system in order to identify the stresses like stress in x direction, stress in y direction, shear stresses. But for that purpose, there are certain essential conditions, and through that conditions, we are trying to identify the condition by which this Airy stress function is used or not. So in case of Cartesian coordinate system, the essential condition to use the Airy stress function is the basic assumptions through which we are carrying the different homogenization or material should be homogeneous, isotropic, continuous. Like this, these are the basic assumptions. But apart from that, del raised to 4 phi is equal to 0. This is the essential condition through which we are considering that this particular condition should get satisfied in order to use this particular Airy stress function. Is it okay? So, during last lecture, we have seen that how to identify the stress in x direction, stress in y direction, and shear stress. So, sigma xx, sigma yy, and sigma xy, how to identify the various stresses. So, Airy stress functions part we have seen. Coming ahead, now we are coming to the new concept, that is the polynomial equation. This is the part of this Cartesian coordinate system. There are different polynomial equations. In the different polynomial equations, the first polynomial equation is the second degree polynomial, third degree polynomial, and higher degree, that is fourth degree polynomial. So let us see first of all the concept of polynomial equation, and then again we will come to the end of this chapter, that is Saint Venant's principle and some practice problems. So before going further with the help of this polynomial equation, let us have the second degree polynomial. Suppose this Airy stress function, by extending the concept of Airy stress function here, the integrating equation 2 times, we are getting the second degree polynomial. In case of Airy stress function, we have seen the del raised to 4 phi is equal to 0. That is the condition. If suppose del raised to 4 phi, we are integrating this fourth degree by 2 times, we are going to reduce, and then it will become the second degree polynomial. Del raised to 4 phi upon dou x raised to 4, 2 times of del raised to 4 phi dou x dou y, and del raised to 4 phi dou y4. So these 3 things are there. Let phi is the function. As usual, we have considered the phi as a Airy stress function. Then del raised to 4 phi dou x raised to 4, del raised to 4 phi dou x2 dou y2, and del raised to 4 phi dou y raised to 4. We are considering that equal to 0 as a basic assumption in case of Airy stress function. But apart from that, by considering the second degree of polynomial equation, or by constructing the polynomial second degree polynomial equation by reducing the degree from fourth degree to second degree by taking 2 times integration. So for that purpose here, by double integrating del raised to 4 phi dou x raised to 4, double integration 2 times of del raised to 4 pi dou x2 dou y2, and dou raised to 4 pi dou y raised to 4. If suppose we are considering this particular double integration concept here, then definitely in the first integration, because when integration of 0 we are taking, then definitely it is some constant value. Means the derivative of constant value is 0, but integration of 0 may be some constant value. So from that point of view, if we study the first integration and second integration, then after second integration we are getting certain function at the location of 0, and that's why this function we have considered to be phi function. So on the right side here we are writing here, we are putting here it as a phi, and this phi indicates that this is the function which is toward the right side. Now the double integration del raised to 4 phi dou x raised to 4 dx plus double integration 2 times of dou raised to 4 pi. Now if we simplify this, the first integration of this del raised to 4 pi dou x raised to 4 is we are reducing the degree from fourth to third, which will become equal to dou raised to 3 phi dou x 3, and by reducing once again this will become dou raised to 2 phi dou x 2. But as the first step of integration, by reducing its degree by 1 and converging that dx, integration of the dx will be considered to be x. So first integration of this particular part of del raised to, suppose we are considering this only first integration, dou raised to 4 phi dou x 4 dx, then its degree will get reduced to dou raised to 3 phi dou x 3, and dx will get converted into x. Then once again if we will take integration here, so after taking one more time it's a integration, then this dou raised to 3 phi dou x 3, that will get converted into dou raised to 2 phi dou x 2, and this x that will get converted into x raised to 2 upon 2 here. Is it okay? So this first part that we have completed here, that is dou 2 phi by dou x 2, and in the second bracket we have written here x raised to 2 by 2, that is dx first of all in integration gets converted into x, and x again gets converted into x raised to 2 upon 2. Now here if we go for this middle part, then in this middle part here we are getting that double integration of 2 times of dou raised to 4 pi dou x 2 dou y 2 with reference to dx and dy. So if we take the first integration here, if we consider this part of the first integration only, then it becomes 2 times of dou raised to 4 pi dou x 2 dou y 2. So though it is not written to here, obviously here dou x 2 dou y 2 is present. Is it okay? So in the first integration, its degree will reduce by dou 3 phi, and one of the dou x 2 will convert into dou x. So 2 is the constant that will come outside the integration, and that will remain as it is. So this constant 2 will be brought outside the integration. In the first integration, its degree will reduce by 1, and in second integration once again its degree will get reduced by 1. So this will become dou 2 phi, and this degree of this dou x and dou y, which was dou x2 and dou y2, that reduces by dou x and dou y. Is it okay? So dou 2 phi by dou x dou y after taking 2 integrations. So 2 outside the integration as a constant part, and reducing this dou raised to 4 phi by dou x2 dou y2 by dou 2 phi dou x dou y. Simultaneously in first integration dou x2 will convert into dou x2 will convert into dou x. In second integration dou y2 will get converted into dou y. So like this, this double, after taking this double integration, this will become 2 times of dou 2 phi dou x dou y, and definitely in the first integration this dx will get converted as integration of dx as x, and integration of dou y as y here. Is it okay? So 2 times of dou 2 phi dou x dou y and xy. So after taking this double integration, we will get this middle term like this. Similarly, for the last term, when we are trying to take the integration here, Then here also this is the fourth degree of the term. So with this fourth degree of term del raised to 4 5 which we are considering here. So dou 4 5 dou y4, and this is with respect to dy. So by taking two times of integration, in first integration this will become dou 3 5 by dou y3, and in second integration this will become dou 2 5 by dou y2. Is it okay? So here we can understand this by reducing its degree by two times, this becomes dou 2 5 by dou y2. Is it okay? In the first integration this dy will get converted into y, and in second integration this y will get converted into y square by 2. Is it okay? So here if we are putting that dou 2 5 by dou x2 is equal to a2, then dou 2 5 by dou x dou y is equal to b2, and dou 2 5 by dou y2 is equal to c2 here, then we will be able to write this particular equation in the form that this basically this two term is present here, and if we divide by 2 all the equation, this will become 1 half, nothing will be here, and here also 1 half. So a2 by 2, so this will become a2 by 2. So here 2 is present here, we have taken this 2 outside here. Already this dou 2 5 by dou x2 which is considered to be a2, and this 2 is present here. So this will become a2 by 2, and this x square will remain as it is. Similarly for this b2, now as far as concerned with this b2 here, this total constant term we have considered to be b2, so this will become b2 xy, and then again this dou 2 5 by dou y2 which is considered to be c2, so c2 upon 2 into y square, like this. Is it okay? So a2 by 2 x square plus b2 xy plus c2 by 2 y square, and which is considered to be equal to function phi. Is it okay? So here we got this particular equation, and that equation represents a2 by 2 x square plus b2 xy plus c2 by 2 y square, which is equal to phi, and that indicates the second degree polynomial equation. Is it okay? So as far as concerned with this second degree polynomial equation, if we try to adopt the concept of Airy stress function here, then in Airy stress function we know that what we have done, sigma xx is equal to dou 2 phi by dou y2. So if we take the differentiation with respect to y, then by taking the differentiation with respect to y here, what we will get? See here, we are differentiating with respect to y. a2 by 2 is present here, this particular part, as we are taking the differentiation with respect to y. What will remain here? In the first differentiation, in second differentiation, in the first differentiation what will be vanish? If we take the differentiation with respect to y, this term will get vanished. Here b2x, that only will remain, because with reference to y, this b2x will going to remain only. Here with first differentiation, this will be 2y, 2 will get cancelled, and c2y, so dou phi by dou y is c2y, and again by taking the second differentiation, what is going to happen here, that c2 is going to remain only, because already this term has been become 0. This particular term after second differentiation, because only b2x is going to remain and we are differentiating with respect to y, so that's why this second term will also become equal to 0. And in this third part, when we are taking the second differentiation, in first differentiation it is 2y, 2 will get cancelled, and in second differentiation only c2 will remain here. So phi is equal to C2, and that's why sigma xx, that will be one constant, and that is C2 we have considered. Similarly, if we try to identify the sigma yy, then sigma yy is nothing but, we know that from Airy stress function, sigma yy is equal to dou 2 phi by dou x2. So let us differentiate this equation with respect to x first of all. So after differentiating this equation with respect to x, we will get dou phi by dou x, and with this dou phi by dou x, so 2x, 2 will get cancelled, a2 x is there. Then here b2 y will present, so with the differentiation of this, b2 y will be there, and this part will become constant with reference to x, and this will become 0. Similarly, with second differentiation, now this middle term is going to become 0, because with reference to this x, now b2y is remaining, and this is considered to be constant, and this will become equal to 0. And only remaining term will be here, a2. So constant values we are going to get here. So constant values for we are getting for the stress in x direction, stress in y direction. In both the direction, the value of stresses will be constant here. So here let us try to understand the concept. Sigma yy is equal to a2, and sigma xx is equal to c2. So sigma xx will become equal to c2 here. Is it okay? Similarly, if we try to understand or identify the sigma xy with the concept of Airy stress function, then we know that with reference to Airy stress function, what we are doing, sigma xy is equal to minus 2 times dou 2 phi by dou x dou y, means once we are identifying the differentiation with respect to x, and then with reference to y. And then if we first of all differentiate with respect to x, then this will become 2x here. So 2 will get cancelled, and 2a2x will be remain. So with first differentiation with reference to differentiation with x, here b2y will remain, and this function will become 0, because with reference to x, this y is considered regarded as constant. So with reference to x, when we are taking differentiation, this term will become 0. When we are taking differentiation with respect to y, this term will become 0. So these two terms, two n terms, will become equal to 0. And for middle term, when we are differentiating with respect to x, first of all, it will become b2y. And when we are differentiating with respect to y, then it will become b2. So minus 2 times of this differentiation, we are taking the minus term for differentiation. So that's why this will become equal to minus b2. Okay, so sigma xy is equal to minus b2. So sigma xx c2, sigma yy a2, and sigma xy minus b2, like this surface get. These are also
सर मायनस कसं आलं समजलं नाही मला.
मायनस म्हणजे आपण जेव्हा एरी स्ट्रेस फंक्शन वापरतो, तेव्हा एरी स्ट्रेस फंक्शन मध्ये ज्यावेळेस आपण व्हॅल्यू आयडेंटिफाय करतो, थोडासा मागचा रेफरन्स मी घेतो एरी स्ट्रेस फंक्शनचा. इथं आपण सिग्मा एक्स एक्स आणि सिग्मा वाय वाय या व्हॅल्यू जेव्हा आयडेंटिफाय करतो, तेव्हा आपल्याला हे एक एक्झाम्पल आपण मागच्या वेळेस सोडवलं होतं. तर सिग्मा एक्स एक्स, किंवा इथं आपण बघूयात थोडक्यात रेफरन्स घेऊयात, सिग्मा एक्स एक्स आणि सिग्मा वाय वाय आयडेंटिफाय करण्याचा अझम्पशनच्या एरी स्ट्रेस फंक्शनचं जे अझम्पशन आहे, त्या अझम्पशनच्या बेसिसवर आपण जर आपण गेलो इथं, we will get sigma xx is equal to dou 2 phi by dou y2. Sigma xx is equal to dou 2 phi by dou y2. सिग्मा yy हे जर आपण इथं बघितलं तर सिग्मा yy काय आहे, dou 2 phi by dou x2. पण शियर स्ट्रेस कॅल्क्युलेट करताना मात्र आपण काय करतो, शियर स्ट्रेस साठी इथं काय आहे, कुठलं साइन आहे, which sign is here, minus sign is there. Is it okay? For sigma xx we are using dou 2 phi by dou y2, sigma yy we are using dou 2 phi by dou x2, but for shear stress we are using minus dou 2phi by dou x dou y. The minus sign आपण purposefully use करतो. So that's why we are going to take this minus sign while identifying sigma xy. Is it okay? Here also if we try to see इथं सुद्धा जरी आपण तुम्ही बघितलं तर आपण dou 2phi म्हणजे सिग्मा वाय वाय कॅल्क्युलेट करताना काय केलं होतं आपण dou 2phi by dou x2. Then for sigma x dou 2phi by dou y2. But for shear stress calculation, what we have used minus dou 2phi by dou x dou y. Minus sign we are using for shear stress calculation, and that's why this minus sign will be continued here. Here also we can see from for previous example also we have used a minus sign, and that's why while calculating this sigma xy we are using this minus sign, and that's why this minus dou 2phi by dou x dou y, that's why this will become minus. Is it clear?
Yes, sir.
So this is related with the second degree polynomial. Then let us see the third degree polynomial here. So for third degree polynomial, again same concepts we are going to use, because in second degree polynomial what we have done, we have gone for this reduction of this polynomial equation 2 times, because initially this if we consider del raised to 4 pi, then its degree is fourth degree, and that we have reduced by 2 times in order to get the second degree polynomial equations. Now here in third degree polynomial, if we set here that phi function, same concept now we are going to apply here. So after application of this concept, that we are in the see here, am I audible?
Yes, sir.
Okay. So with this second degree polynomial, we got the equation a2 upon 2x square. Now we are going for third degree polynomial. Once again we are taking its a differentiation. So after taking differentiation, suppose any other constant, so here x raised to 2 is present, then what will be in the integration? X raised to 2 plus 1 divided by 2 plus 1, that is x cube upon 3. So x cube upon 3, but already 2 is present here. So 2 into 3, that will become equal to 6 here. So one more integration we are going to take here. So after taking one more integration on both sides, that is left side as well as right side, here we have taken 2 times integration. One more integration is taken here. Then we got that a3 is okay. So this constant term a2, b2 and c2, these terms we have used as a constant term. a2 is constant, b2 is constant, c2 is also constant term. Likewise in third degree polynomial we are using the constants, and here we have defined this as a3, b3 and c3. So let us take first of all the integration on both sides. So as this is third degree polynomial equation, to the right side always we are considering this as phi only. Is it okay? So same thing is used here. Phi is the third degree polynomial equation. So here a3 upon 6 and x square, so that will become x raised to 3 upon 3. So a2 upon 6 a3. So this new constant now name is given as, because integration has certain constant term that is going to add. So that's why this is a3 is termed as the constant multiplier of this x term. So a3 upon 6 is equal to a3 upon 6 into x cube. Similarly, for this middle part b2xy, now after taking its integration, we know that there is one multiplication rule of the integration. First function as it is integration of second minus in integration sign, the integration derivative of first and integration of second. Is it okay? So that rule we are applying here. If we take the integration of this particular part here, by applying that rule, we will get once again this first function as it is integration of second plus second function as it is integration of first. Is it okay? So first function as it is, that is x, and integration of second, that is y square by 2. But in second case, that is integration of second term and derivative of second term and integration of first term. Is it okay? So if we apply this rule here, then by considering the constant as middle term, second term as a b3 constant, third term as a c3 constant, this will become equal to x square y, and in second case this will become xy square here. Is it okay? Are you getting this middle term, integration of this middle term? Have you understood this middle term b to xy? We have taken the integration. So by taking integration of this middle term, first of all x square y and then xy square. Is it okay? So this term and remaining, these are the constants, because in case of integration we know that every stage of the integration new constants are going to add, and that's why the third degree polynomial, these constants we are denoting with the help of a3, b3, c3, d3, indicating that these are the constants coming after taking third integration. Is it okay? And similarly for the last part here, once again this will be equal to c2 upon 2. So if we take the integration here, then this is going to become y2. So y2 means after taking integration this will become y raised to 3 divided by 3. So integration of y2 is y raised to 3 divided by 3, and this divided by 3 into 2, this will become 6. So y raised to 3 upon 6, and this next constant we have used here this as d3 constant, because these are the constant terms a, b, c, d. These terminologies always we use for constant term. So that's why this function phi, so that will be expressed in terms of this a3, b3, c3 and d3 form. Is it okay? Now, as usual, if we try to identify the stresses in x direction, stress in y direction, and shear stress, let us have this stress in x direction first. Then definitely sigma xx is equal to dou 2 phi by dou y2, sigma yy is equal to dou 2 phi by dou y2, and sigma xy is equal to minus dou 2 phi by dou x dou y. Is it okay? So here, if we take the first differentiation of this dou phi by dou y, and second differentiation, this will become dou 2 phi by dou y2, and this is nothing but sigma xx. So in order to identify the sigma xx, we will have to take two differentiation of this equation with reference to y. Is it okay? So let us check here that after taking that differentiation we will get a3x, because this term x raised to 3 is present here. In first differentiation this will be 3x square, and then 6x will get cancelled, and this will become a3x. Similarly for middle part, when we are differentiating with respect to x 2 times, then what will happen, that first differentiation 2x, and in second differentiation this will become 2 will get cancelled here. The remaining term is y only. In this case, with reference to 2 times of x, this term will get become 0, and this term will also become 0 here. So here we should understand this how this sigma xx, sigma yy has been carried, and sigma xy is carried. Is it okay? So any doubt with this? Anybody any doubt this? With regular notations, this third degree polynomial is also identified. And same thing is repeated once again here. So in order to identify the fourth degree polynomial, here we have once again integrated that term. So after integrating the term, we will get function phi, because whatever the function we are considering, that is the function after fourth degree polynomial. So a raised to 4, x raised to 4 upon 12. So you can check this particular function, how this comes as once again, if we are taking, because here we are taking now integration of this term here. So you can understand this particular total term which has been obtained after taking integration of this step. So this is third degree polynomial, and in order to get the fourth degree polynomial, once again its integration has been taken. So we get this particular term here. Is it okay? So once again this term of phi has been obtained here, and the stresses in x direction, stresses in y direction, and sigma xy, that is obtained here. Is it okay? So you can understand here this sigma xx, sigma yy, and sigma xy with usual notation in simple manner, how this polynomial equation, the concept of polynomial equation has been introduced in Cartesian coordinate system, and how these derivations of the Cartesian coordinate systems are obtained here. Is it okay? Now we are coming to the last part of this. So before going to the last part, we will go for practicing some few examples. But before that, we will finish the last bit from this chapter. So this last bit is the Saint Venant's principle. Is it okay? So this principle is very, very important. Saint Venant's principle we are considering here. The principle states that if forces acting on small portion of the surface. Now here, before going to or understanding this particular principle, let us understand that one cantilever beam is in front of us, and on that cantilever beam at its one end, the force has been applied. Suppose on any one cantilever beam is present, and on this cantilever beam, so suppose like this, force is applied from the top. Is it okay? For any cantilever beam, if suppose any load is applied at its end, then what is going to happen? That after applying this particular load on one of the end, so is it possible? I will check that here this facility is present. Whiteboard, this facility is present here. Are you able to observe here one whiteboard? Are you able to observe here one whiteboard? Bhushan, Manoj, are
Yes,
you
sir.
getting?
No, sir.
Are you getting this whiteboard here? Are you
Ye-
getting?
Yes,
Are
sir.
you
Yes, sir.
yes, sir.
whiteboard दिसतो सगळ्यांना इथं?
Yes,
Yes,
sir.
sir.
Yes, okay. So now we are understanding the concept of Airy stress function. We will come to Airy stress function, but before that, let us check that. Let us see. Suppose this is any cantilever beam, and on this cantilever beam, I am applying load here. See, are you observing this load and this cantilever beam here? So from this end, this is support is given here. Are you getting this figure? Are you observing this figure?
Yes, sir. Yes, sir.
So cantilever beam is there. One on one end, this is fixed. At another end, one arrow is shown here in downward direction, which indicates that this kind of load is applied here. Now see that with reference to this Saint Venant's principle, now keep in front of you this figure, and by keeping this figure in front of you, let us come to this part of Saint Venant's principle. One by one thing we will understand, we will try to separate from this and we will understand. The principle states that if forces acting on small portion of the surface of an elastic body are replaced by another statically equivalent system of the force. You see, once again we will come to this figure. Now force is applied here. This part is elastic. Is it okay? Here, this cantilever beam is elastic part. Here we will consider this body as elastic body. Is it okay? So this is elastic. So for this elastic body, if we consider that force is applied at one end, then basically at this, what is our regular practice? If we try to solve this example, or if we are using the concept through which we are now analyzing the force. Suppose we are trying to analyze the force. So this is our cantilever beam. So with this cantilever beam now, this force is applied here. This force we are going to keep as it is, which is shown here. Is it okay? Then this support we will change with two arrows. Suppose this is one arrow. Let us see. This is one arrow. With the help of this arrow, we are going to give the support. And this is one another arrow. Is it okay? So this support system, which is at the left side, now we have replaced with these two arrows. Are you getting these two arrows? हे दोन arrow आपल्याला लक्षात येत आहेत?
Yes, sir.
So this at the left side, basically this was fixed. But in order to solve this problem, what I have done, this support system I have replaced with the help of these two arrows. Out of this, the first arrow is the upward direction. That means whatever the downward forces, same forces are in upward direction also. So upward and downward forces are same. So wherever the support is given here, so that support will definitely bear the total downward forces and it will give this support in upward direction. Is it okay? So to the left side, in upward direction, one arrow is shown here. So this downward arrow is balanced with this upward force. So downward forces are equal to upward forces. Is it okay? Like this, we can justify this. Is it okay? So here we can understand that this particular downward force, so which is balanced by this upward force. Is it okay? Are you convinced with this? Okay. Now, second thing is that due to this application of this force, means now this force is applied here. Due to application of this force, moment is going to generate to the left side. Okay, moment is going to generate to the left side. Then, in order to balance that moment, this kind of arrow is shown here. Okay, so this kind of arrow is shown here. So this moment will move in this direction. Is it okay? So this particular force will generate a moment in clockwise direction, and in order to balance this, one anti couple or this in opposite direction, one couple is required, and this couple is shown with this help of this arrow. Is it okay? So this particular force is acting in downward direction. At the same time, it is as there is certain distance up to this particular line. So due to this distance and this force, some couple is going to form, and in order to bear that couple, so here what we have done? We have given one more arrow, and that arrow is representing equal and opposite direction of the arrow. So we will consider that the couple is balanced. So with this particular vertical arrow, we are balancing the force, and with this couple, we are balancing. So the couple generated due to this force. Is it okay? So moment generated with this force, that will be balanced with this arrow. Is it okay? हे लक्षात येते?
Yes, sir.
Okay. Now once again we will come to the Saint Venant's principle. Now the principle states that if forces acting on small portion of the surface of an elastic body are replaced by another statically equivalent system of forces acting on the same portion of the surface. What we have done here? We have replaced this particular support system which is shown here. This is the support system. This support system we have replaced by one vertical force and one couple here. Is it okay? So this vertical force and this couple that we are replacing. So if forces acting on small portion of surface of an elastic body are replaced by another statically equivalent system of forces acting on same portion of the surface. So what we have done? We have done the redistribution. Is it okay? See here. So this we are considering to be redistribution. If I remove all these things, then this is a redistribution. So this support, which is redistributed by these two kind of support, this particular support which is shown here. So for that, we have used one couple and we have used one upward force. Is it okay? So couple and upward force both are the redistribution of this support system. Is it okay? So here word purposefully is used in Saint Venant's principle is the redistribution. Is it okay? So this is considered to be redistribution, and that produces substantial change in stress locally. Is it okay? So there will be effect locally, but have negligible effect on stresses at a distance which are large. Is it okay? So if there is any question in anybody's mind that this particular support system which is shown here fixed, because this kind of arrow we have, this kind of description we are showing to fix the so in order to demonstrate that this is the fixed at one end, then here two arrows we have used. So this is one kind of redistribution. Then whether there is an effect of this redistribution? Yes, there is effect of redistribution, and that effect of the redistribution will be locally, but that have negligible effect on globally. Is it okay? So here the support system we are changing with the help of these two forces, but there will not be any significant effect globally. There will be effect in locally only. Is it okay? So that's the Saint Venant's principle states. So here statically equivalent system means the distribution of forces have same resultant force and moment. Here same resultant force and same resultant moment we have considered, and that's why this principle is one of the tool enabled to simplify the problem by altering boundary conditions. So already this Saint Venant's principle we have used in analysis of mechanical element, which was the subject used in second year, maybe strength of material or analysis of mechanical element you have studied, and this indicates that this local distribution or redistribution of forces is one of the tool, and with this the problems can be solved, and that is the effective tool given by the Saint Venant and that's why we should understand, we should try to clear the concept of state venance principle which is introduced here. Is it clear? Is it clear to all?
Yes, sir.
Yes, sir.
Indrajit Vadgave?
Yes, sir.
Okay.
Yes, sir.
Okay, okay, no problem. So, like this here, we have completed the first chapter, but still we have to practice some problems on Airy stress function. Is it okay? So for next lecture, two problems of Airy stress function. Once again, we will repeat here how to draw the diagrams by using this and how to identify the stresses. So two practice problems we will complete in next lecture, and here our first chapter will be completed. So from university guidelines, your few syllabus will be also reduced. Maybe 10-20% syllabus will reduce from this part, from this subject, all subjects of the MTech mechanical design, because your semester has been started late, and your examinations will be probably from the 5th May, so 26th April or 5th May. Is it okay? So most probably it will be 5th May, but you consider that in the last week of the April or first week of the May, there will be your theory examinations for this all the subjects. So from that point of view, you should be ready for examinations, and so you should